Jai Hind, ladies and gentlemen. Aviation Safety India takes a great pleasure in welcoming you all for this video presentation on the importance of correct altimeter setting. Number of serious accidents or serious incidents have occurred due to incorrect altimeter setting. Having felt the need to refresh the memory of the pilots on the correct altimeter settings, this video presentation has been prepared for the knowledge and safety of the pilots. I am sure that you will find the video presentation educative and interesting. Let's get moving to the video presentation. Incorrect altimeter setting and lack of awareness among pilots about the importance of correct altimeter setting has caused many accidents or near accidents. The aircraft/helicopter altimeter barometric subscale must be set to the appropriate setting for the phase of the flight. Failure to set the appropriate barometric subscale pressure setting may result in a significant deviation from the cleared altitude or flight level. Aircraft pressure altimeters indicate the elevation of the aircraft above a defined datum. The datum selected depends on the barometric pressure set on the altimeter subscale. Sound altimeter setting procedures are an essential tool in ensuring safe separation from the ground and from other aircraft. The SI or metric unit of measurement for barometric pressure is the hectopascal. 1 millibar is equal to 1 hectopascal. Standard altimeter setting is 1013.2 millibars or hectopascal. Inches of mercury, it is mainly used in North America. Standard altimeter setting 29.92 inches. Millimeters of mercury, it is used in CIS and some other Southeast European states. Standard altimeter setting is 760 millimeters. Now let's have a look at the QNH. What is QNH? QNH is the pressure set on the subscale of the altimeter so that the instrument indicates its height above sea level. The altimeter will read runway elevation when the aircraft is on the runway. Airfield QNH is obtained by correcting a measured QFE to sea level using ISA, regardless of the temperature structure of the atmosphere. As your altimeter is calibrated using ISA, it will indicate altitude correctly at the airfield reference point. At other altitudes, the indicated altitude is likely to be in error depending on the temperature of the atmosphere. Now let's have a look at the QFE. QFE is referred to as atmospheric pressure at aerodrome elevation or at runway threshold. The pressure set on the subscale of the altimeter so that the instrument indicates its height above the reference elevation being used. QFE is the isobaric surface pressure at the reference point. At other altitudes, the altimeter will give an indication of the height above that reference point. With the aerodrome QFE set in the subscale, your altimeter will read 0 on the highest point on the runway and at other altitudes will read the height above the airfield elevation. For precision approach runways or for instrument runways, when the threshold is 7 feet or more below the aerodrome elevation, the QFE may be based on the threshold elevation. With the runway threshold QFE set in the subscale, your altimeter will read 0 on the runway threshold. Let's have a look at the QNE now. QNE is different to the other altimetry Q codes in that it is an altitude and not a pressure. With standard pressure, that is 1013.2 millibar set, an aircraft altimeter indicates pressure altitude, flight level, and is used by all aircraft operating above the transition altitude to provide a common datum for vertical measurement. The standard pressure is equivalent to the air pressure at mean sea level in the international standard atmosphere. Now we'll discuss the definition of flight level and altitude. Flight level is standard pressure setting 1013.2 hectopascal is set when flying by reference to flight levels at or above the transition level. Altitude, regional or airfield pressure setting, that is QNH, is set when flying by reference to altitude above mean sea level at or below the transition altitude. Height, altimeter pressure setting indicating height above airfield or touchdown. QFE is set when approaching to land at airfield where this procedure is in use. Note that this setting is not used in other portions of the flight, climb, cruise, and initial descent. Now we shall discuss the transition altitude, transition level, and transition layer. First, the transition altitude. The altitude at or below which the vertical position of an aircraft is controlled by reference to altitude. Transition level, the lowest flight level available for use above the transition altitude. And transition layer, the transition layer is the airspace located between the transition altitude and the transition level. Aircraft are not supposed to fly level within the transition layer. When passing through it, their vertical position is expressed in flight levels during the climb, that is about transition altitude, and altitude during descent, that is below the transition level. If no transition altitude and transition level are defined, which is common for en route flights outside the TMAs, the vertical position of the aircraft shall be expressed in terms of flight levels at or above the lowest usable flight level, altitude below the lowest usable flight level. Now let's have a look at the effect of change in pressure on altimeter reading. If the altimeter is not set to the current altimeter setting, When flying from an area of high pressure into an area of low pressure, the altimeter will overread. Flying from low pressure to high pressure, the altimeter will underread. An inch of mercury error in the altimeter setting equals 1000 feet of altitude. Cold air is denser than warm air. So the altimeter will indicate a higher altitude than the aircraft's true altitude. When the temperature is warmer than standard, your altimeter will indicate that you are lower than you actually are. This means you are at a higher altitude than your altimeter shows. We shall now discuss types of altimeter setting error. One reason can be that the pilot mishears the transmitted pressure setting and sets an incorrect figure. The pilot hears the transmitted pressure setting correctly but fails to set it or missets it. The pilot fails to change the pressure setting at the appropriate point in a departure, climb, descent, or approach. What are the adverse effects? Failure to set the appropriate pressure setting can result in deviation from the cleared altitude or flight level, leading to level burst, loss of separation from other traffic, collision with other aircraft, and controlled flight into terrain. Loss of situational awareness due to failure to appreciate the significance of a pressure setting, especially QFE as opposed to QNH. This can result in an incorrect appreciation of the closeness to the ground, possibly leading to an unstabilized approach or collision with the ground, that is, controlled flight into terrain. What are the defenses for these errors? Effective standard operating procedures, which specify appropriate procedures for the setting and cross-checking altimeter, barometric subscales. Strict adherence to the verification of pressure, altitude, derived level procedures by ATC. This should be done at least once by each suitably equipped ATC unit. The check is performed by comparing the level received from surveillance sources with a voice report by the pilot. System support. The transponder always transmits the level information as flight level regardless of the pressure setting. The ground system then converts this information to altitude/height. Pilot errors. How the pilots make errors in altimeter settings. Pilot fails to ensure that standard pressure is set when passing the transition altitude in the climb and level the aircraft at a flight level that differs from the cleared level by an amount dependent on the difference between the QNH and 1013.2 hectopascal. A pilot fails to set QNH when passing the transition level in the descent and level the aircraft at an altitude that differs from the cleared altitude by an amount dependent on the difference between QNH and 1013.2 hectopascal. A pilot unfamiliar to landing with QFE set does not remember that the altimeter now indicates height above airfield elevation or touchdown zone. Now, what are the solutions? Firstly, the existence of appropriate SOPs for the setting and cross-checking of altimeter subscales and their strict observance. Use of the aircraft radio altimeter to monitor the aircraft proximity to the ground can help to improve situational awareness, provided that the flight crew is generally familiar with the terrain over which they are flying. Ground proximity warning system oblique terrain awareness and warning system provides a safety net against controlled flight into terrain, and in the case of terrain awareness and warning system class A, with its option of a simple terrain mapping display, it can also be used to directly improve routine situational awareness of the pilots. We shall now discuss operational and human factors involved in altimeter setting errors. The incorrect setting of the altimeter reference often is the result of one or more of the following factors: high workload, deviation from normal task steering, interruptions and distractions, and absence of effective cross-checking and backup between crew members. The analysis of incidents oblique accident reports identify the following operational and human factors as causes of or contributing factor to altimeter setting errors. First of all, incomplete briefing, that is failure to discuss applicable altimeter setting unit and the country practice for fixed or variable transition altitudes oblique levels. Workload during descent oblique approach. Distraction oblique interruption. Language difficulties, that is unfamiliar accents, speaking pace, unclear contraction of words, mixed English oblique local language communications. Failure to cross-check altimeter setting information, for example, ATIS versus tower messages, pilot flying oblique pilot not flying, cross-check. Fatigue of the crew members, confusion between altimeter setting units, excessive number of instructions given by ATC in a single message. Confusion between numbers such as 5 and 9, that if 9 is pronounced as 9 instead of niner, and oblique or incorrect listening associated with ineffective readback or hearback loop. Lack of emphasis on flight operation briefing on effective pilot controller communications. We shall now discuss prevention strategies and personal lines of defense. First of all, adherence to the defined task sharing for normal or abnormal oblique emergency conditions, and the use of normal checklists are the most effective lines of defense against altimeter setting errors. Awareness of the altimeter setting unit in use at the destination airport. Awareness of rapid QNH oblique QFE changes due to prevailing weather conditions, that is extreme cold or warm fronts, steep frontal surfaces, semi-permanent or seasonal low pressure areas. Awareness of the anticipated altimeter setting using two independent sources for the cross-checking, example METAR and ATIS messages. Effective pilot flying, pilot not flying, cross-check and backup. Adherence to SOPs for sterile cockpit room. Change of barometric altimeters setting in climb and descent. In climb at the transition altitude and in descent when approaching the transition level and when clear to an altitude. Use of standby altimeter to cross-check main altimeters. Altitude callouts, including the radio altimeter in the instrument scan. When the radio altimeter is alive, that is below 2,500 feet radio altitude. Radio altimeter callouts. Setting the barometric altimeter MDA oblique height or DA oblique height or the radio altimeter decision height. Exercising extra vigilance and cross-checking if QFE is used for approach and landing. The following prevention strategies should be considered by air traffic controllers. Limiting the number of instructions transmitted in a given message, indicating all the numbers and the unit, defining the altimeter setting. Adhering to the standard phraseology and pronunciation. Adopting the accepted terminology, low before a 28 point something inches altimeter setting and high before a 30 point something inches altimeter setting. Let's have a look at the radio altimeter callouts. Radio altimeter callouts can be either announced by the PNF or the flight engineer. They may be automatically generated by synthesized voice. The callout should be tailored to the operating policy of the operator and to the type of approach. To enhance the flight crew's terrain awareness, a call-out radio altimeter alive should be announced by the first crew member observing the radio altimeter activation at 2,500 feet height AGL. The radio altimeter reading should then be included in the instrument scanning of the remainder of the approach. Radio altimeter readings, that is feet above ground level, below the minimum obstacle clearance, values listed below should alert the flight crew. In initial approach segment, that is from initial approach fix to intermediate fix, 1000 feet. Intermediate approach segment, that is from intermediate fix to final approach fix, 500 feet. Final approach segment, that is after final approach fix, for non-precision approaches with a defined final approach fix until visual references or reaching minimum approach point, 250 feet, unless the airport features high closing terrain. The radio altimeter reading, that is height above ground level, should reasonably agree with the height above airfield elevation. Aviation Safety India is grateful to each one of you for your time and attention to watch this video presentation. It is essential that the pilots are fully familiar with various aspects of correct altimeter settings. Knowledge of different units of altimeter settings, conversion of one setting to the other, errors of altimeter, and importance of cross-check between pilot and co-pilot are of paramount importance. Pilots should be aware about the operational and human factors involved in altimeter setting errors. Maintaining high standards of situational awareness through knowledge of terrain, minimum and route, off route, and safe altitude, And correlation with standby altimeter and radio altimeter can go a long way in preventing accidents due to wrong altimeter settings. Wishing you all very happy and safe flying and many happy landings. Jai Hind.